Bismillahirrahmanirrahim. Welcome back to my channel. I'm back with a video, and this video requires a very big setup. We're actually going to look at the operation of a mixer. So for that, I'm using my vector generator, vector network analyzer, as another source of RF generation. Then I have my RF generator that is being used for as an LO, local oscillator for my, and for IF I'm using my HackRF now as a spectrum analyzer, and I have my famous software which is running, which is Gqrx. Just to review the principles, let me leave this here. How does a mixer works? I made a video on it. I've used GNU Radio to actually make a video on it. Just to give you an idea, mixer is basically an IF, which you need. And if it's going to be a local oscillator minus whatever the frequency that is coming into the port, if you subtract them, take an absolute value, you will get an FIF. So you need three frequency: IF, FLO, and FRF. FRF is the incoming frequency, FLO is being generated by a local oscillator, and FIF, which is an intermediate frequency, that is the output of your mixer. So let's look at the mixer. So this is basically on your computer screen. This is how does the mixer operation works. So we're interested in IF frequency, and especially we're looking at a down conversion frequency. So for that, let's look at our mixer. So the mixer that we are doing, the mixer that we have under test is actually a mixer by mini circuit. As you can see, it has a frequency range from 1600 all the way up to 6 gigahertz. I have my local oscillator, which is right here. As you can see, that is connected to my RF generator. This is my local oscillator, which is connected to my RF generator. My IF is connected to my HackRF because I'm using HackRF as a spectrum analyzer. Then I have my FRF frequency that is being generated by my vector network analyzer. As you know something about vector network analyzer, we do this to test S11, S12s, S22s, and S12s and 21s for a two-port network. You can also use that as a frequency generator as well. So I'm going to show you how I'm using this as a frequency generator though. Why I have this setup. So if I just wanted to show you my setup is quite big. As you can see, I have my function generator, which is RF function generator, that is going into my mixer. Then then I have another signal that is coming from my VNA, and the output of all of this is going into my HackRF, and my HackRF is running on PC. So why do I have a setup like this? Why? Because the VNA that I have is actually a two-port VNA, and mixers are three-port devices. Now, if I were to buy a three-port mixer or a four-port VNA, that is going to be very costly. So this setup is like a cheap way of testing your mixer. It's not actually cheap, but this is what I have available here. That's what I'm using. That's why I'm using this setup. So I have my RF generator, which is using as a local oscillator. I'm using my VNA as my RF source, and then IF is being monitored using HackRF and Gqrx software. So the idea is quite simple. We're going to do down conversion, and we're going to see how is my mixer is working perfectly fine, or what's going on. We're going to look at basically we're trying to characterize my mixer. So how are you going to use your VNA to generate frequency? As you know, when you're performing S11, S12s, and S22s, and all these measurements, S parameter measurements, actually ports, they generate a dummy signal and they send it to your DUT, and based on that you're calculating the reflection. So in any VNA, they have an option called sweep. You can go to sweep, like I'm going, and go to sweep type, go to continuous mode, go to sweep control, and just go to sweep, and then go to start on this. I'm going to choose my frequency. I'm going to choose my power to be negative 10 dBm because I don't want to burn down my HackRF, which is because I'm using my HackRF as my generator. I'm choosing my frequency to be 1.2 gigahertz for testing purposes. So 1.2 giga. Let me just change this frequency to 1.2 giga. Let me just come back here and show you indeed the frequency is 1.2 giga. Now this is start sweeping. I'm getting a frequency that is coming out and going into my mixer input, and I'm treating that, I'm calling it as an FRF. All right, and the local oscillator is being set here using my function generator. That function generator is giving out a frequency of 4 gigahertz. The power is not on. This is the way I'm going to turn on my power, and I have my HackRF which is running in, and this would give me that IF. So basically what I'm trying to look for is actually FIF, which is this. So FIF is going to be FLO minus FRF. So in our example, just to test my mixer, my FLO is actually 4 gigahertz and my FRF is around 1.2 gigahertz, as you can clearly see. Now what I'm going to do now, I'm going to leave this as is. I'm going to leave this as is. So now what I'm going to do, I'm going to show you this. I'm going to turn on, I'm going to run my favorite software, which is actually my HackRF that is connected to Gqrx, and I'm going to turn this thing on. So the frequency that I'm interested in, and so it's going to be this. So the frequency is going to be this. So FLO, FIF is going to be FLO minus FRF. So FLO is 4 gigahertz, 4 minus 1.2. So I should expect to see a frequency which is around 2.8 gigahertz. So I should see a spike here at around 2.8 gigahertz. So now what I'm going to do, I'm going to turn on my RF on. As soon as I turn on my RF on, you can clearly observe this, that you have a frequency at 2.8 gigahertz, which is right here. So you can also observe this. I'm just going to simply turn this off by pressing RF off button. So RF off is turned off and the spike is gone, which means my mixer is currently operating. It is performing the task that it's supposed to perform, and so down conversion is happening perfectly fine. So I can do that. I can try it with different frequency. I can change this frequency to, let's say, instead of having 1.2 gigahertz, or I don't know, let's change the frequency here because this is easier for me to change this. So instead of 4 gigahertz now, let me change this frequency to 3 gigahertz. Let's see if I can do something. 3 gigahertz. So now let me just leave it to 10 dBm and then I'm going to change this frequency to 3 gigahertz. Now 3 minus 1.2, if I were to do my calculation right, 3 minus 1.2, leave this over here. So 3 minus 1.2, I would expect to see a frequency which is 1.8 gigahertz. So let's check this out. So right now this is tuned to 1.8. So let me just tune this frequency to 1.8. So 1.8, and now I'm going to turn on my RF on, and here are the spikes. So I can clearly see there's a lot of things which is happening. All right, let's do one more thing. So this is in terms of down conversion. So right now at down conversion, mixer output is actually consists of FLO minus FRF, FLO plus FRF. So my FLO is 3 gigahertz, which is right here, and the frequency that is being generated by my VNA is 1.2. So lower frequency is 1.8. Now it's supposed to give me a higher frequency at 4.2. So because my HackRF is capable of generating frequency up till 6 gigahertz, so let me just change this to 3 plus 1.1 is 1.2, 4.2. So let me just change this to 4.2. Let's see if I have something happening at 4. Here we go. 4.2. So my mixer is perfectly operating. I'm going to turn off my RF off. So you're going to observe this. I'm just basically turning off my RF off. And let's see. All the spikes are gone. Now I'm going to turn it on again. And you can see. So it is working perfectly fine. The mixer is operating good. It's actually performing up conversion. It's also performing down conversion. using the setup that I have here. You need two function generator, and you need about a spectrum analyzer to actually look at the performance of your mixer if you don't have 3-port or 4-port devices available. This is probably the cheapest way you can check your mixer. If you also had like two generators, you could have performed the same thing using a spectrum analyzer. But I was just giving you one idea that you can use this. HackRF is an amazing device. You can use this to do a lot of things, which is sort of unbelievable. I mean, you can use it as a spectrum analyzer, as a transmitting device, as a receiving device, as an antenna analyzer, and things like that. So if you all have any questions, leave it in the comment section. Don't forget to like and subscribe to my channel.